Hello, my name is Alexandros Konstantinou, and I'm happy to introduce my work on pseudo-Brauer relations, isogenies, and parities of Selmer ranks. The main motivation for my work comes from ideas found in the works of Birch-Castles, Mazur-Rubin, and Coates for Kaya, Cat, and Sujatha concerning the use of isogenies to answer questions surrounding parities of ranks of abelian varieties. This is where we find the parity conjecture, which predicts that the rank of the Mordell-Weil group of an abelian variety is determined by local constants, specifically the so-called local root numbers. The main advantage is that these local invariants are independent of deeper properties of L functions, which makes them easier to compute. It should be noted that in general the parity conjecture is still an open problem, and all progress towards this conjecture usually relies on the use of some isogeny between abelian varieties, which allows one to deduce the existence of some local formula which expresses the parity of the rank of the Mordell-Weil group in terms of local invariants, usually Tamagawa numbers. Then, in order to prove the parity conjecture, all we need to do is perform a detailed comparison between the local Tamagawa numbers and the local root numbers. And this is how one usually proves the parity conjecture. So motivated by these ideas and relying on joint work with Vladimir Dokchitzer, Holly Green, and Adam Morgan, in this paper we proceed along two interconnected directions. Firstly, we offer a unified framework for constructing classical isogenies using group actions on curves and finite group representation theory. In particular, we revisit various instances of classical isogenies, including cyclic isogenies between elliptic curves, genus 2 Jacobians which split into a product of two elliptic curves up to isogeny, and Richelot isogenies between genus 2 Jacobians, and then we verify that all of these can be constructed using certain relations in finite group representation theory. We call these relations pseudo-Brauer relations. Then we apply the theory of regulator constants to these pseudo-Brauer relations to study parities of Selmer ranks using an explicit local invariant. Specifically, we show that regulator constants provide a systematic framework for deriving all known local expressions for parities of ranks of Jacobians found in the existing literature, and this recovers results from the works of Birch-Castles, Cranwell-Tannel, and Dokchitzer, among others. All right, and this concludes my presentation. Thank you for your attention, and I hope you enjoy reading my paper.